All right, so to review a little bit of our factoring, I'm going to go over the three main methods that we went over in the past: the Gcf method, difference of squares method, and the product and sum method. Now, each of those methods you can see I've already done some examples for you on the worksheet I handed you. And I'm just going to go through those same examples but explain them. So you can already see them already worked out on your paper, but I'm going to work out each of them and just talk you through what I did. So let's start with the Gcf method. The first example is 6x to the third plus 15x squared. So when it comes to the Gcf method, you're looking for a greatest common factor. That's what Gcf stands for. So you're looking at the two terms in this polynomial here, and you're trying to identify what factors they both have in common. Now, basically meaning what can you divide both of these terms by? So 6 and 15, first and foremost, both 6 and 15 are divisible by 3. And you want to choose the biggest number that they're divisible by. And 3 is the biggest number that will divide into both 6 and 15. So 3 is part of the GCF. I'm just going to write it off to the side here. 3 is part of the GCF. And then also look at the x's. So the first term has x to the third, meaning it's got 3 x's in it. And the second term has x to the second, which means it has 2 x's in it. Each term has at least 2 x's. So as far as what they have in common, they have at least 2 x's in common. So the GCF is 3x squared. They're both divisible by 3. They both have at least an x to the second power. So what you're going to do is you're going to divide both terms by that 3x squared. So divide this term by 3x squared and the second term by 3x squared. So that GCF that you're dividing out isn't just going to disappear. We're kind of putting it in front of the polynomial. So imagine, this had parentheses around it. Well, now what you're doing is you're taking the 3x squared and you're putting it in front of those parentheses. Okay. And then inside the parentheses is what's left after you've divided that out. So for the first term, 6x to the third divided by 3x squared. 6 divided by 3 is 2. And x to the third divided by an x squared. Remember, you kind of subtract the exponents. So if you had 3 x's, but you're taking 2 of them away, then you're going to have just a single x there, or x to the first. So that's 2x. And then 15 divided by 3 becomes 5 for the next term. And then x squared divided by x squared means all the x's cancel out. So there is no x in that term. So that is factoring by GCF. That's how you get that answer. And a good way to check, remember, is factoring is just the opposite of multiplying or distributing in most cases. So if you were to take this answer we just got and distribute this back, you would get what we had originally started with. So 3x squared times 2x, 3 times 2 makes 6. X to the second with an x makes an x to the third. And 3x squared times 5, well, 3 times 5 makes 15. And x to the second, no other x's in this term, so it remains x to the second. And you can see that's exactly what we started with. So that's the reason why you have to make sure whenever the GCF is, whatever you're dividing by, you put it out front. Because if you don't put it there, then there's nothing for it to distribute back into. So make sure the GCF goes out front, and make sure you divide cleanly to get the leftover part in the parentheses. So the other GCF one, I'll just kind of work out quickly. 4x to the third minus 12x squared plus 14x. So again, you're looking at all of these terms. Now this polynomial has 3 terms in it. So you have to look at all 3 of them, not just 2 in particular. And do the same thing. What can we divide all 3 terms by? 4, 12, 14. All 3 of those numbers are divisible by 2. And 2 happens to be the biggest number that you can divide them by. So as far as GCF goes, 2 is a part of that GCF since all these terms are divisible by 2, and that is the biggest number you can divide them by. Now, as far as variables go, the first term has an x to the third, so it's got 3 x's in it. Second term has 2 x's in it. The last term has just a single x in it. So as far as what they have in common, they each have in common at least 1 x. So an x is part of that GCF as well. So the GCF is 2x. So what we're going to do is we're going to divide each of these terms by 2x. And like I said, that 2x that we're going to divide by, that's going to basically be divided out of the polynomial. It gets moved to the front of the polynomial. So again, imagine there's parentheses on this. that 2x you're dividing out of each term is going to be in front, because remember at the end you could distribute this 2x back and get what we started with. But we'll get there when we get there. So as far as dividing goes, the first term, 4x to the third divided by 2x. So 4 divided by 2 becomes 2. And x to the third divided by an x. So you have 3 x's and you're taking 1 out. So it'll just be an x to the second. And the second term, negative 12 divided by 2 is going to be a negative 6. And as far as x's go, x to the second divided by an x means you'll have a single x remaining. And then the last term, 14 divided by 2 is 7. And 1x, taking away 1x means that those x's are going to cancel, so it isn't going to be an x there. So that is your answer, all done there. So like I said, if you want to check to make sure that it was done right, you should be able to distribute this back into your polynomial and get what you started. So 2x times 2x squared would be 4x to the third. 2 times negative 6 would be negative 12, and x makes that x squared. And 2x times 7, 2 times 7 is 14, and then it brings that x as well. So you did get what you started, but as far as final answers go, this is our final answer, right? But yeah, it's nice to check sometimes. All right, so moving on to the next method, difference of squares method. Difference of squares is very straightforward. You don't have to do a whole lot of thinking. You just have to make sure you know how to do square roots. So as far as the first example goes, you're just looking for what's the square root of each term. So what is the square root of x squared? What is the square root of 25? You need to know those things. Now, square root of x squared is just x, and square root of 25 is 5. So basically, what happens here is x squared is made up of x times x, and negative 25 is made up of 5 times 5. Well, really 5 times negative 5, because it is a negative 25 after all. So what we have here, basically, to finish factoring, you just pair one of these x's with one of these 5s, and together that's x plus 5, because it's an x and a positive 5. And then you pair the other x with the other 5, which is the negative, and that makes x minus 5. So you pair them together, that's your answer. X plus 5, x minus 5. It's always going to be 1 plus and 1 minus. And remember, difference of squares is always going to have a subtraction sign here. There should always be that subtraction sign. If it's a plus sign here, it's not going to work the same way. So it has to be a minus sign. And as long as it's a minus sign, you can do exactly what I did here. Just make sure you know what the square roots are, and then pair those numbers up. And again, to check to see that this works properly, if you distribute or FOIL this back together, you should get what you started with. So if you FOIL this, x times x makes x squared, x times negative 5 is negative 5x, 5 times x is positive 5x, and 5 times negative 5 is negative 25. And so these two middle terms, negative 5 plus 5, they cancel out, leaving you just with x squared minus 25, which is exactly what the problem was to begin with. So remember, FOILing, distributing, all that multiplying is just the opposite of factoring. Factoring is the opposite of what we've been doing before. So the other difference of squares problem was 9x to the 4th minus 16. So again, this is the same thing, just a little bit trickier. So you need to know what the square root of 9x to the 4th is. You need to know what the square root of 16 is. Now, as far as the square root of 9x to the 4th, just do the square root of each of these one at a time. The square root of 9 is 3, and the square root of x to the 4th is x to the 2nd. So remember, you're always, as far as exponents go, you always take half of it when you do square roots, and half of 4 is 2, so that's why it's x to the 2nd. Square root of 16, I think we know, is 4. So as far as the pairs go, we have 3x squared and a 3x squared to make up the 9x to the 4th, and we have a 4 and negative 4 to make up the negative 16. So just like on the last problem, you just pair one with another. So you have 3x squared with positive 4 as a pair, and you've got 3x squared with the negative 4 as a pair. Now, it doesn't really matter if the plus is first and the minus is second. You could have the minus as the first group and the plus as second, so it doesn't matter which is which. As long as you have those two groups, you're all set. So again, if you want to, you can FOIL these out and see that they work. So 3x squared plus 4 times 3x squared minus 4. So 3x squared times 3x squared is 9x to the 4th. 3x squared times negative 4 is negative 12x squared. 4 times 3x squared is positive 12x squared. And 4 times negative 4 is negative 16. So just like the last problem, a negative 12x squared and a positive 12x squared, these like terms cancel each other out. So you're just left with 9x to the fourth minus 16, which is what we started with. Now for the final method, the product and sum, this is probably the most important method. So let's go over it carefully. Now, for this method, it's used when you have a quadratic, ax squared plus bx plus c. And to solve it, you need to first multiply a times c and put that number in the top corner of this x thing. This is known as the product, and we'll get to that in a second. And then put the b value in the bottom part, and this is called your sum. So our example, we have x squared plus 11x plus 24. So as far as ax squared bx plus c goes, our a is 1 because it's 1x squared. Our b is 11 because 11x, and our c is 24. So to set this up, this is just the setup. We're not factoring anything yet, but this is just to set it up and help us figure out our numbers. You take the a value, which is 1, and you take the c value, which is 24, and you multiply them together. 1 times 24 is 24. So I'm going to put that number in this top corner just as a way to organize my thinking. And then the b value, which is clearly 11 here, I put down at the bottom corner. So now I try to solve this puzzle, because what I've made here is a puzzle. I want to figure out what two numbers are going to multiply to the top number 24. So multiplies to the 24 and adds to 11. It has to be the same combination of numbers, a pair of numbers that multiplies to make 24, the same pair of numbers that add to make 11. So I need to figure out what two numbers will do this. So these two numbers in this case are going to be 8 and 3. 8 times 3 is 24, and 8 plus 3 is 11. So my two numbers that this is where I start my problem now with these numbers, 8 and 3. So what I'm going to do is I'm going to go back to my quadratic, and I'm going to use the two numbers I just got. I'm going to use them as x terms, and I'm going to use them to replace the original x term. So the 11x I'm going to throw out, and in its place, I'm going to put these two numbers instead. So I still have x squared, and I'll still have 24 at the end as well, but in between them, instead of having 11x, I'll have plus 8x and plus 3x. Now 8x plus 3x, if you combine them, is 11x, so I haven't changed the value of anything. But what I'm going to do now is I'm going to use the four terms that I have, and I'm going to factor by grouping. So I'm going to group the first two terms together and the last two terms together. So it always works this way, the first two and the last two. And also, by the way, it wouldn't matter if you had written 3x and then 8x. It would still work exactly the same way, so don't get too concerned about the order of those terms. As long as they're in the middle, you're fine. So group the first two terms together and group the last two terms together. And now factor each group by GCF. So the first group, GCF, you're looking at what do those two terms have in common? Well, you can't divide numbers by anything because you have a 1x squared and 8, so you can't really divide those numbers by anything other than 1. But they both have an x term in it, so they both have at least an x. So you're going to take that x and you're going to factor it out of that group. And remaining x squared divided by x leaves you an x. And 8x divided by x, those x's are going to cancel. So it would just be 8 for the second part. And now for the second group, GCF again, these two terms, now 3 and 24 are both divisible by 3. So I'm going to divide that 3 out, and I'm going to put that in front of these parentheses. And remaining 3x divided by 3 is just going to be a single x, and 24 divided by 3 is 8. So now at this point, you should have the two GCFs should factor into the same binomials. X plus 8 and x plus 8 are the same, not by coincidence, they're supposed to be the same. So that x plus 8 is going to be one of the factors in my answer because that's a common factor for these two groups. And the other factor is consisting of the part I factored out, the x on the outside and the plus 3. That makes up my other factor, x plus 3. So my answer is x plus 8 and x plus 3. Now, what I want to do is just to explain again what I did on the previous problems is if you FOIL those together, if you take your answer, x plus 8, x plus 3, if you FOIL it back together, you should get the same binomial we started with. So x times x makes x squared. X times 3 makes 3x. 8 times x makes 8x. And 8 times 3 makes 24. And then when you combine these terms in the middle, you have x squared plus 11x plus 24. So factoring is always the opposite of the distributing, the FOILing, the multiplying. Factoring always undoes those things. So that is your product and sum method. I'll just do that one more example just to talk you through it if you need some explanation. So you have 2x squared. Let me put it off to the side a little more. 2x squared minus 9x plus 10. So it's the same setup as before. Take your a times your c and put it on the top. So in this case, a is 2 and c is 10. Because remember, it's ax squared plus bx plus c. So a is 2, c is 10. So 2 times 10 is 20. So that number's going to go on top. And then the b value, which is negative 9 in this case, will go at the bottom. So again, you have to solve the puzzle. What two numbers will multiply to make this 20? So multiply to this and add to 9. So what two numbers multiply to make 20? Same two numbers add to make negative 9. In this case, both numbers are going to be negative. I know both numbers are negative because two negatives multiply to make a positive, but two negatives will add to make a negative as well. So I know they're both negative. So it tells me it's negative 4 and negative 5. Negative 4 times negative 5 is positive 20. Negative 4 plus negative 5 is negative 9. So my two numbers are negative 4 and negative 5. Now I'm going to start my factoring. So this whole time I'm just trying to solve this puzzle to find these numbers, but I'm going to use these numbers to start factoring. So remember, what I'm going to do with these numbers is I'm going to take them and use them as x terms to replace the original x terms. So these are going to take the negative 9x place. So when I write my polynomial out, I still have 2x squared, and I'm still going to have 10 at the end. But in between them, instead of having 9x there, I'm going to have negative 4x and negative 5x. And just like the last problem, I'm going to group the first two terms together and the last two terms together. Now keep in mind, I have to keep the negative with the 5, so I wrapped the negative inside the parentheses there. All right, so the first group, as far as GCF goes, 2 and, let me make that look more like a 4. Okay, well, that's a little better. 2 and negative 4, both divisible by 2. And both these terms have an x in them as well, so I'm going to factor a 2x out of that group. And so 2 divided by 2 will cancel, and x squared take an x out, so that'll leave me an x there. Negative 4 divided by 2 will be negative 2, and then those x's will cancel, so it'll just be x minus 2. As far as the second group goes, I can divide them both by 5. However, I'm going to divide by a negative 5, and I'll show you why in a second. So dividing by negative 5, I'll take the negative 5 and put it out front, which means the negatives cancel, the 5s cancel, leaving me with a positive x, and then 10 divided by negative 5 leaves me with negative 2. So the reason I divided by negative 5 was because I needed this binomial to match the same thing I got the first time. So the first time I had x minus 2, so I needed this one to be x minus 2 as well, because it's supposed to be the same. And I knew that if I divided by a negative, then the negative that was with the x would go away, and the positive that was with the 10 would become a negative, so it would match up. All right, so again, my final answers, notice x minus 2 is the common factor, so x minus 2 is one of the factors in my answer. So once I've dealt with the x minus 2, the other part of my factor is the outside, the GCFs, the 2x minus 5. That makes up the other factor, 2x minus 5. And so there's your answer. So again, if you want to check your work, let me erase this so I have some space. If you want to check your work, you certainly can. X minus 2 times 2x minus 5. If you FOIL it, you should get back what you started. So x times 2x is 2x squared. X times negative 5 is negative 5x. Negative 2 times 2x is negative 4x. And negative 2 times negative 5 is positive 10. And then you combine your like terms in the middle, you're going to have negative 9x. And then you bring the other terms down. So you get the same thing you started with, but remember, we're looking for the factors, so those factors are the answers. All right, that's going to be it, guys. I hope it helps a little bit. I'll see you tomorrow.